Hello everyone. This is the second recording. In the previous video, I briefly talked about what is LSOM. So I talked about operations management, service operations management, and logistics or supply chain management. Okay. In this second video, I want to talk about some social value of LSOM area from a standpoint of business analytics. Okay? So to be specific, I want to talk about what is digital transformation, what is business analytics, and one missing piece in this argument is culture inference. So I'll talk about these three aspects, and then I'll introduce one of my research paper as an academic example. So, what is digital transformation? I think most of you have heard about digital transformation in recent years. Okay, if you think about old days, okay, when people shown in this picture lived, okay, at that time in the old days, they don't really have a lot of data. Okay, um, they may have to write down the data with pen and pencil, right? As you can imagine, easily imagine that contains a lot of errors. Right? There's typos, sometimes you mistakenly add one more zero. So the numbers shown in the table in the paper has a lot of mistakes. And if you want to analyze the data, these papers needs to be collected into one place, right? Uh, one one paper is in one area, the other paper is located far away from here. You have to collect everything together so that you can basically analyze the data. In this process, it's very easy to lose some of the papers. Okay, and as I said, it's quite scattered. So in these old days, it was really hard to say there is a data. Okay, even though there is a data, something written in the paper, still it's very, very hard to analyze data, right? However, these days, I think you all agree that there are lots of data, okay, especially after the COVID-19 situation. Let me give you an example based on my daily routine. Okay. When I wake up every day, the very first thing I do is check my body um, body composition using this in-body weight. Okay, so I can see how much protein I have, how much fat I have, so I can see all the numbers, and that also allow me to track the historical information. So I can see what was my body composition yesterday, 2 days ago, 3 days ago. Okay, so you can visually see the changes. Okay, you can easily check this change with your smartphone or website. Okay, after that, I open my Kakao map or Google Map or Neighbor map to see how to commute. How to commute. So what's the best way to go to Korea University? Okay, so it will give me the best route to drive. If I have to take a public transportation, it will also give me the detailed information in terms of when the bus arrives, what is the shortest path, okay, etc., etc. And also this the Google Map um, records all of your historical information, so I can see which place is the most frequently visited place, where is the newly visited place, and I can see how far I walk in the last month and how long I took a bus, etc., etc. So that becomes my other data point. Then I go to gym and I open a body calendar. So every day I record which body part I focused on during in the gym. Okay, I can focus on my shoulder, my back, okay, my body, the core body, leg, etc., etc. Okay, so and also each time I can record what was the weight I exercised with. Okay, so every day I want to add a little bit more weight or at least one more repetition. In my office, I have a wide screen. On the left-hand side, I always have my Gmail, so I can see all the Gmail. I can see all the mail, inbox and outbox. On my right-hand side, I have Google Calendar. So again, it allows me to see what happened in the past. I can see all the schedule, all the tasks that I've completed. Okay, so as you can see from my daily routine, it's quite easy to see that there are lots of data available. Okay, so while we move around, we generate lots of information. So I think lots of platform companies like Kakao or Naver or Google, we agree that they have lots of customer information. However, you may wonder whether those manufacturing companies have such a detailed information or not. So I have one example here based on Hyundai Motors, right? So this is traditional manufacturing company, okay? So I had an opportunity to collaborate with Hyundai Motors. So I was able to see what kind of data they have. So I noticed that they collect a lot of data based on each vehicle. Okay, so they know these location. So basically, the place I depart and place I arrive and number of sudden acceleration and number of sudden stops. So that is measured to give a safety score, okay? And level of gas when refilling the gas, and any alert message shown in the dashboard, etc., etc. And then the temperature, um, so things like that. So using this data collected, as I mentioned, they create, they calculate something called safety score. So basically, if the number of sudden accelerations and number of sudden stops is less than few numbers, um, then they collaborate with Hyundai, Hyundai Haesang, basically the insurance company, okay, based on Hyundai. If the score is greater than, let's say, 90, the car insurance price is discounted by 7%. No, 5%. Okay, so they already use this information. Um, okay, so surprisingly, many companies, not just service companies or platform companies, even those manufacturing companies, they do have lots of information about customers. So basically, I just feel that digital transformation is nothing but um, the if the amount of data becomes extremely large these days. Okay, so not just including both service and manufacturing companies, they tend to have tons and tons of data. So the question they have these days is how to utilize this data. And I think that basically business analytics. Okay, so once the company realized that they collected a lot of data, okay, in the very beginning, they just collect data without knowing how to use. Okay, um, so the first thing they did is to hire some of the data scientists, okay, who has typically computer science major who knows how to write a code, okay, so high ability of code, okay, and later on they realized that um, the data scientist cannot communicate properly with those senior managers. That becomes a huge problem. And the CEOs and senior managers, they come to the business school in the United States like 20 years ago, and then started to mention that please educate those people who can bridge these two different parties, the data scientist and senior managers, and that becomes the business analyst. Okay, so who can bridge two different parties or translate because the data scientists and senior managers are using different languages. Okay, so the business analyst need to understand the coding and the business as well. Okay, also they must have some ability to analyze data and visualize. Okay, so those senior managers, they have huge working experience, typically more than 10 years of working experience. They have insights about their specific business or industry. Okay, so the role of business analyst is quite simple. Oops. When they hear something from senior manager, they said, okay, I have some insights about the future. Okay, blah, blah, blah. Um, when the business analysts listen, the senior managers, they must able to understand what those senior managers talking about. Okay, so that's why they need to understand the business, and then they have to basically translate those senior managers' language into the language where the data scientists can easily understand. So basically, they have to understand how to code, so must deliver to the data scientists that, okay, to show this insight, please analyze ABC database, and then, especially use some specific code, blah, blah, blah. And that scientists, they are experts in coding. They will do all the data cleaning and get back to the business analyst, okay, with some sort of table, a summarized table. Then the business analyst must analyze the data and then also have to translate the language from data scientist to the senior manager one more time. So in this time, the visualization becomes key. Visualization. Because the senior managers will have a hard time to understand the table. So the figures, some charts, they're much better than providing tables. Okay. In fact, this is not something new. It's been introduced in the US somewhere like more than 15 years ago. Okay, so on the right-hand side, you can see a list of schools where they are ranked based on their business analytics program. So you can see the MIT provide a good program, Carnegie Mellon University, Georgia Tech, Wharton School, okay, NIU, Berkeley, UT Austin, and Booth, University of Chicago. So they all provide really good business analytics program. Okay, that was the phenomenon I witnessed when I was in the United States as a professor. Okay, so the MBA becomes plateau. Okay, it's not growing like 20 or 30 years ago. And people have some doubts about MBA program. Okay, so as the MBA gets plateau, the business schools start to offer this master's program in business analytics, and that enrollment and application numbers gets doubled and sometimes tripled each year. In Korea, Korea University Business School is the first to provide this MSBA program. We introduced this program in 2020, um, and we have another, affiliation who help to promote this MSBA program that is called Center for Digital Transformation and Business. Okay, and also many firms they start to emphasize this business analytics capability. For example, Samsung Electronics, they have big data center, which is managed directly by the CEO. And GS, they have AI center. Shinhan Bank, they really emphasize the digital transformation um, in their banking industry. Okay. So I briefly talked about what is digital transformation and business analytics. Now, this is something actually I recorded in the YouTube video. So the causal inference is very important, but sometimes students, well, not just students, many people misunderstood this. So I often see people get confused about this. So people tend to think that digital transformation and business analytics is identical to um, AI and machine learning. But that's not true. Okay, AI and machine learning. This is just a tool. Okay, so this is a tool for the business analyst. Okay, and also people tend to think that the artificial intelligence and machine learning will give you all the answers. Okay, and they often interpret the result based on um, machine learning and AI as of causation. But not true. Most of the time, they only give you correlation, and causation and correlation is completely different thing. Okay, correlation is just co-movement in a particular direction. Okay, does not imply causation, and causation is cause and effect. So here's some example. Okay, so here, let's focus on the last one. Here, the dark blue represent the sales of new cars in the US, and the lighter blue is the number of visitors to the Universal Orlando's Island of Adventure. Okay, they are just co-moving. In other words, they have high correlation because they are moving together. When one goes up, the other one also goes up. When one goes down, the other one also goes down. But it does not mean that one causes the other. Okay? You cannot say that sales of new cars drive more visitors to the Universal Orlando's Island of Adventure, or we cannot say that more visitors to the Universal Orlando drive more sales of new car. They're just co-moving. It's really important to clearly see that what is causal inference. Okay, so here I provide a definition of cause and effect. That is a relationship in which one event makes another event happen. Okay, so one event called a cause, the other event is cause effect, called effect. And the causal inference, okay, which is not equal to just machine learning, or artificial intelligence. Okay. The causal inference is a process of identifying a causal relationship of a particular phenomenon from observational data. And this is not just what I emphasize. These are the things that scholars, these are the things that actually allow those scholars get a Nobel Prize in economics. So in 2019, okay, Michael Kramer, including Michael Kramer, three scholars got a Nobel Prize they because of their experimental approach to alleviate global property. The experimental approach, this is one method to establish the causal inference. And in 2021, Joshua Angrist and Guido Imbes, they got the Nobel Prize for their methodological contribution to the analysis of causal relationship. Okay, so these are the things. The causal inference is really important, not because I emphasize. That's also emphasized by these popular and well-known scholars. There are a lot of methodologies to establish the causal relationship. Okay, of course, I cannot talk about all the details. I just want to mention at least. So there is a difference in differences, instrumental variable approach, fixed effect model, regression discontinuity, match method, synthetic control. Okay, these are at least a few skills or tools to establish the causal relationship. So here, when people say a AI or machine learning, they usually think about like some decision tree or lasso model or neural network. Okay, they are purely prediction. In other words, it will give you only the correlation information. So you cannot interpret the result based on these pure AI or machine learning result as of causation. Of course, there are other methods as shown in this box here. Some methods under the machine learning, they allow us to interpret as of causal inference. Okay, so we have to be careful. Okay, we should not interpret the result based on the AI and machine learning as of causal. Okay, that's what I want to emphasize. Okay, so if you want to know more about the business analytics, actually in KUBS we have track system. So by taking these basic required courses, including business statistics, BA1 and 2, these are the mandatory courses. And then you can take three other courses among these elective courses. So by taking 18 credits, which is 6 courses, you can get a certificate indicating that you fulfilled a business analytics track at Korean University Business School. Okay, so I highly recommend those undergraduate students to utilize this information. If you want to know more about BA, maybe you can consider joining the MSBA program, as I briefly mentioned. So you can learn about let the data speak for itself. Okay, it was first in Korea, and then this is 1 year program. Okay, you can finish all things within 1 year, but there's no vacation. So it has 6 modules, 8 weeks each, so which is about 2 months. So 2 months times 6 modules, that becomes 12 months. So within one year, you can finish everything. And another unique aspect of this MSBA program is capstone project. essentially you got the data from actual companies and you will do some sort of mini consulting job. Okay, so you don't have to write a master's thesis. This capstone project um, is replacing the master's thesis. Okay, um, these are the list of companies that work together for the capstone project. As you can notice, there is like large companies like Hyundai Motors, um, LG, right? And there are some consulting firms, PwC Consulting, and some retail, such as and Eden, okay, some pharma companies, okay, so there are lots of different companies. And those students who graduate from the MSBA program, they joined good companies like Samsung, LG, Hyundai, um, Microsoft, PwC Consulting, etc., etc. Okay, so that was a brief introduction about digital transformation, business analytics, and then coder inference. Now, I want to talk about my research. Okay, as I mentioned in the previous video, I uploaded this article in the Blackboard. So if you're interested in, you can more than welcome. You're more than welcome to read this paper. Okay. So I think you all have experience of buying a clothes or fashion products. Okay. Um, so this is mainly about those fashion products. And I think you all have experience of ordering something through online. Okay, so we witnessed a intense competition between brick and mortar. This is a physical, okay, physical or um, offline retailers versus online retailers. So if you look at the year-over-year growth, sales growth, online stores have like 10% growth every year. Okay, while the brick and mortar stores have only 3.5% in 2013. So, but still, if you look at the entire market size, the brick and mortar has much larger portion than online. Okay, but at that time when the Amazon first introduced and grew so rapidly, people say that there is a retail apocalypse. Okay. No more, they're so afraid about the situation. The Amazon take 6% bite out of the brick and mortar retailers, and people say there's no malls in the US since 2006, no new malls. And 15% of the current malls in the US are expected to close in the next 10 years. So they're so afraid. But that did not happen, right? Like 10 years later, right now, we all see that people still want to go and feel the products in the physical store. Okay. One thing that can explain why people do that is the five-stage consumer purchase decision process. Okay. Basically, these Angel et al. They argue that people first need to uh, recognize a need or problem. And let's say, oh, my smartphone is now working properly, so I need to buy a new phone. And I'm going to search some information. And let's see what are the information available phones out there. And then I'm going to evaluate only a certain candidate, okay, within in your consideration set. Okay. So I'm not going to buy a Huawei phone, for example. I'm going to buy only Galaxy or Apple. Then the Galaxy and Apple, they are within the consideration set, while all other products are not included in the set. Okay, and then I'm going to evaluate these two alternatives, the Galaxy and the Apple phone, and compare and figure out, okay, I'm gonna buy Galaxy Fold. Okay, and then you can do some post purchase evaluation. If you like the product, you can write a review, or you can talk about these good things to your friends, family, etc., etc. Okay, um, and there is another interesting phenomena, something called showrooming. Okay, so sometimes people go to the physical store to touch and feel the product, right? You can go to the Samsung store to feel the Samsung phone, and you can see, you can play with the phone. And then what consumers do is actually open their smartphone and search and online. Okay, and then they will say, "Oh, I find a cheaper price, and I'm gonna buy online." That is called showrooming. Same thing happens if you go to the physical store for the clothes. You find something you like, and then people do not buy immediately. They check the price online, and sometimes they place an order from this online place. Okay, so about 50% of online shoppers first check out the product in the brick and mortar store, and then they eventually buy from online. So that's even worse for the offline stores because customers utilize all the resources from physical store, and then they buy product from the competitive online stores. Okay, that's the worst thing. So those brick and mortar retailers, they they use a different techniques to beat the showrooms. Target, for example, offered exclusive products not found elsewhere. So essentially, certain products they are only available in Target stores. You cannot buy anywhere else. Walmart, they are known for their, you know, outperforming number of stores. So essentially, um, if you visit the United States, Walmart is almost everywhere. Okay, so they allow consumers to pick up at the in-store freely for the online order. And then they also have another online channel so that they help each other. Online retailers, they're not stupid, so they also respond by opening a offline channels. So, for example, here the Warby Parker, they are like eyeglass retailer. They initially sell all products through catalog, okay? And then they sell through online. And so what they perform initially is that customers can pick 10 different frames, okay? And then Warby Parker send those 10 eyeglasses so customers can have these 10 glasses for 1 or 2 weeks period. They can feel, touch and feel and see whether it fits well or not. And then if they like, they can buy one and send 9 back to Warby Parker. And if they don't like, they will send those all of the 10 glasses back to Warby Parker. And all of these shipments are paid by Warby Parker. Okay, so as you can imagine, Warby Parker essentially paid a lot of money for the delivery cost. Okay, and later on, what they did is just open a showrooming store. So that's a place where customers stop by and touch and feel the product. Okay, that was opened a in large cities such as New York City, Seattle, Chicago, etc., etc. Okay, the showroom is different from actual retail store because showroom does not contain inventory. Okay, customers can touch and feel the product, the glasses, but when they want to buy the product, they still need to make a purchase through online. Okay. Later, Warby Parker saw a significant positive impact of this showroom on their revenue. So they opened actual retail store where they also carry a lot of inventory. So now consumers can visit the Warby Parker store to touch and feel, and then they can also buy the glass immediately. Um, Under this background, our main collaborator is a brick and mortar store. So we focus on brick and mortar store, and from their perspective, they want to increase their sales by enhancing customer experience so that they have a goal to make those customers open their wallet within the store. Okay, how can they do that? There are largely three ways to do so. One, they can distinguish the customers from the browsers. They can provide service at the right time to the customer, and they might be an opportunity to cross-sell the right product. In that perspective, especially for the fashion product, the apparel product, the fitting room has an important role. Firstly, it can filter the browsers. According to this Muslim et al.'s paper, those fitting room users has a higher probability of purchase and large basket value. The basket value is how much you spend for one transaction, okay? Compared to those people who do not use fitting rooms, okay? So maybe those fitting room users are more likely to be a customer, okay? So if I were a store manager, then maybe I will ask my staffs to more focused on those people who use the fitting room because they're more likely to be a customers rather than this browser. And fitting room is a core pathway. So among the five stages I mentioned before, those information search and evaluation of alternatives are performed within the fitting room. And the fitting is has a cross-selling opportunity. So this is an actual quote from the store manager. Is that the women they can accessorize with the handbags, their soap, there's hair accessories, there's scarves, even fragrance. Okay, so you may notice that right next to the fitting room area, there are lots of some easily put together items like hats, bags, belt, etc., etc. I believe you all have experience of using fitting rooms, so I'm going to explain this fitting room process very quickly. Okay, so once you go to the physical store, you will browse the items or on the store shelf, okay? And you will figure out which one you want to try on in the fitting room, okay? Maybe you can put some of the items, and if you have like few items that you want to try on, then you go to the fitting room. If there is a waiting line, you have to wait, and then you can use the fitting room, can try on those items, and then you, depending on the policy of the store, you may leave behind those unwanted items in the fitting rooms. And if you find something you like, you can purchase and exit. If you don't like anything, you can just leave, or you can go back to your sales floor to repeat the process if you need more information. From the items perspective, those unwanted items will be replaced, relocated to the recovery rack from the fitting room, and then it is it will go back to the right place from the recovery rack. There are a few things that I want to emphasize about the fitting rooms. So the fitting room is typically a self-service, okay? Because there is no monitoring, right? It's not possible to look inside of fitting rooms while customers changing their clothes, or they have very limited monitoring. Sometimes they check how many clothes they carry into the fitting rooms. So that's why I said limited monitoring. So because of this self-service feature, the service time, in other words, the occupancy time, okay, how long they want to occupy the fitting room, the occupancy time is determined by customer. Okay. In many other service, the service time is determined by service provider. So the service provider, the company can easily manage the process. However, in this case, the managers or staff, the store associates cannot manage the fitting room service time. One Achilles gun in the brick and mortar store is like bad experience, and bad experience can happen because of congestion. Okay, I'm not sure whether you or when you have experience of visiting any store, retail store in the US during Thanksgiving. It's highly congested. So many people go there. So this very crowded store can negatively affect customers' experience. Okay, it will bother people to perform the information search or evaluation of alternatives. So eventually, the sales may drop. That's what we thought. In the fitting room, if there are lots of people, then you have to wait longer. And some people hate to wait, so they will just abandon. Okay. And there could be some phantom stock out. So as you can see in the picture, there are lots of leftover in the fitting rooms. Okay. And sometimes if the particular item is the only available item and the people um, outside in the floor may not able to find the item they are looking for. So they may think that item is stock out even though the item is in the store. Okay, so that is what we call phantom stockout. I'll talk about that later in detail. And because of these dirty rooms, people hesitate to use this fitting room that will increase the waiting time for other fitting rooms. Okay, so under these, we had three research questions. One, what is the impact of congestion on sales? And what is the plausible mechanism for it? So once we understand the reason and mechanism for it, then we can provide some potential solution. And we not just want to provide a solution, we also want to quantify the value of the solution. To answer the research question, we use a three methodology. Okay. For the first research question, we use archival data analysis to, and for the second research question, we use a field study, and for the solution, the third one, we use field experiment. These are the key findings from our study. So using archival data analysis, essentially, this is like business analytics. So we obtained data from the retail chain for more than 1 year period. We found that there is a inverted U-shaped relationship between the fitting room traffic and sales. Okay, so essentially there is a period where more fitting room visitors and high congestion result in lower sales. That was quite surprising. And then we found that uh, the reason for this, one possible explanation for this is a phantom stockout. And we found this using a field study. Basically, I observed the customer's fitting room usage in the department store for 1 month period. And finally, to provide a potential solution, we performed a field experiment. Okay, so the field experiment is one example of causal inference. Okay, so I'm going to talk about these three in detail. Part one, analyzing archival data. Again, we want to answer the question, that can congestion lead to drop in sales? To answer that, we obtain data from two companies. Okay, so we first get the data, the traffic data from Retail Next. So Retail Next is a third-party video technology company. Okay, so they first approached to us, and their goal is quite clear. They have such a good system. Basically, they install cameras at the entrance of the store and within the store, and it allowed them to monitor, track how many people actually enter the store and where they move. Okay. So they can check customer arrival patterns, customer pathways. So their objective was simple. They want to promote their technology. They want to show the value of their technology and their data so that they can get more client retailers. Okay. So we said, no, just with the traffic data, we cannot show the value of your technology. So you may need to persuade one of your client companies to share their other detailed information. So we got the point of sales data and the labor data from another company called, we just say retailer A, that is a large US-based apparel retailer. So that has more than 100 stores across 20 different states in the US. So for the point of sales data, we have every transaction details. So we have such as the sales amount and number of transactions. And for the labor data, we have the scheduled labor, the more detailed description, whether the labor is full-time or part-time, or which department they are allocated. Okay. For the analysis, we merged this data into hourly level. Okay, we have a 15-month period data. One important thing, although we had 100 stores, only one store, no, 100 stores, they have a camera installed at the entrance of the store. However, only one store had additional cameras within the stores, which allow us to track customer movement within the store, including the number of customers who used fitting rooms. So we focused on only one store in this particular work. Okay, so on the left-hand side, you can see the camera located on the ceiling. Okay, and that captures customer movement into the fitting room. So there is actually two bars. So if the customer passed the two bars in a particular sequence that captures by in count, if they pass the two lines on opposite order, that is counted as out count. So we have every like timestamp for those two events. And also you can notice here that right next to the fitting room entrance, there is a handbags, okay, for the cross-selling. This is his econometrics model, so you don't have to know too much details, but basically I want to understand their sales movement based on number of fitting room traffic, how many people who use the fitting room, and the square term, because we hypothesize nonlinear relationship. We have to include a lot of controls. So how many people actually enter the store, not just fitting room, how many employees were working at that time, and whether it was under promotion or not, and then hourly block and day of the week dummies. So essentially Monday morning is totally different from Saturday night. Okay. And also we include the monthly dummies because January is totally different from November. Okay, this is result, estimation result. It's not easy to understand from the table, so I draw a figure. As I mentioned before, we found inverted U-shaped relationship. So as we have more and more people visit the fitting room, we initially see more sales, right? That makes sense because more traffic is typically considered as higher revenue, and that's why marketing folks have a lot of advertising and promotion to bring more traffic. The underlying assumption is that more traffic results in um, higher sales. But we noticed that here there is a dropping period where when we have too much traffic, too congested, then actually sales is actually lower than our expectation. That was quite surprising because that's counterintuitive to the conventional wisdom. Okay, and this illustrates the importance of managing congestion. Yes, more and more traffic, higher traffic, that converts into higher sales. But if there is a too much traffic, too much congestion, we have to manage the congestion properly. Otherwise, sales is lower. We performed a lot of robustness check. You can just skip this. Um, but essentially, using all different methods, they all increase our confidence that there is an inverted U-shaped relationship. Okay, so now we have to think about why it happens. Okay, to answer that, I did a field study. Okay, so I observed customers' behavior to understand the underlying mechanisms and motivate the potential solution. So I got an interesting idea. So I have a conversation with my wife because I'm not shopping lover, but my wife is shopping lover. So I asked her about why it's happening, why sales can decrease when um, the store or fitting room is congested. And she said something like this: maybe the way I use the fitting room during the congested period is different from the way I use the feeding loop during normal condition. So that was an aha moment. And I go to, I looked through a lot of literature and found that there is some evidence showing that people behave some sort of unexpected way when they encounter congestion. Okay, so maybe there is a congestion-driven behavior which can negatively impact other customers. So let's think about this example here. There is a one person here, and this is speedy checkout counter where they only allow 20 units. Um, and this person said maybe just one more item. Okay, so that he put in 21 items. Just one more item may not be a big deal, but if everybody behind this person has the same behavior, then the waiting time for others will be increased. Okay, and this kind of behavior will be even worse in a self-service environment because there's nobody's watching. Okay, so we call this behavior as impeding behavior, and we define that impeding behavior is any behavior that disrupts others' information search and evaluation alternatives or both during the congestion period. So essentially, the congestion make people show impeding behavior that bothers others' information search and evaluation of alternatives. That's why we drop sales. And what are the impeding behavior in the fitting rooms? Okay? There's two ways. One, say let's say customers usually bring three items at once and go to the fitting room and then get back to the sales floor and bring another three items, use the fitting room, and decide whether to buy or not. So let's say they typically visit fitting rooms twice with three items. But let's say there are lots of customers around you. Okay, what we'll do? So people, you may want to reduce your number of visits to the fitting rooms because you don't want to go through the long waiting time. Okay, so rather you may bring more clothes into your fitting room. Okay, so this way, okay, I'm gonna have 6 items and I'll visit only once. In in doing so, I need to wait just once, not twice. Okay, but as you bring more clothes into the fitting rooms, you have to occupy your fitting room longer than previous case, and that will increase the waiting time for other customers. And some customers hate to wait, so they may abandon, so that's why the sales can be decreased. Another possibility is that um, customers not only just bring more clothes into the fitting room, they may leave behind more clothes into the fitting rooms, and that can create a phantom stock out problem. Okay, so that's why some people cannot find the items they're looking for because the item is misplaced in the fitting room area, and the sales associates cannot clean up the fitting rooms by placing back those misplaced items into the correct place because they are too busy to help other customers directly. So I essentially observed customer behavior over a 3 weekend period. Okay, I initially wanted to observe the same store, retailer A, but we don't have any retailer A's store in the North Carolina area where I performed my I got my PhD. So I observed a different retail chain called Retailer B, but they sell similar products. Okay, this is actually a picture. So this is a department store, and fitting room area is here. Okay, and there is a recovery rack. Within the fitting room area, there is 1, 2, 3 rooms available. Okay, so basically, I observed customers entering the fitting room area. Okay, and you know that was a female apparel brand. Okay, so this is women's fitting room. So if I were here, that um, that that looks very awkward, right? I'm a male, right? So we hired a female research assistant who stayed here and observed customers entering the fitting room. And I asked her to collect 3 information. One, see how many items they carry into the fitting room. That was easy because people tend to bring the hangers together with their clothes. So she can just visually count the number of hangers. And then second, she need to check the time when the people enter the fitting rooms. And then three, actually 4 information. Three, when they exceed, count how many items they carry out. So we can easily see how many items are left. And fourth one is the time they exit the store, exit the fitting room. So this is one evidence consistent with our impeding behavior in terms of bringing more clothes into the fitting room. So as you can see here, with respect to the non-congestion period, those people who enter the fitting room during the congested period bring on average 1.38 items more, and that require them to occupy the fitting room on average 2 minutes more. So that's evidence for the increased waiting time. Okay? So that provides an kind of preliminary evidence for the first impeding behavior. Now, before I show you the evidence for the second one, I want to show you actual picture inside of the fitting room area. Okay, so this is actually a picture. As you can see, there are lots of items within the fitting room area. So I found that there's no cleaning up in the fitting rooms for the 2 hours period that resulted in 70 items dying in the fitting room. And this was the checkout counter, but as you can see, the recovery rack is already um, fully packed, and there are lots of other unwanted items misplaced here. So it's no more checkout counter. So I saw that there are about 156 items in the recovery rack and adjacent checkout counter. Okay. So when I talk about this to the store manager and the executive manager, they said, "Oh, we knew about it. We knew about the problem of misplaced items, but they had no idea about how severe this problem is." Okay. So here, again, compared to the non-congestion period, those congestion period, customers tend to left on average 3 more items in the fitting room. So that shows this impeding behavior. But that does not say that there is an increased phantom stockouts. The reason is as following. Um, if there is a exact, so if there is exactly same size, same color item available in the sales floor, then the leftover item is not phantom stockout, right? Customers still can find the items they're looking for. So only if when the item left over in the fitting room is the only available item in the store, and that's the phantom stockout, right? So I have to check that. So I scanned 559 items misplaced in the fitting rooms, and I noticed that 216 items out of 559, about 39%, were the unique item in the store. So in other words, the phantom stockout rate is very high, 39%. The store manager said, "Oh, that's maybe because of the extreme sizes, too small or too large. So they carry many items in the middle size, but they carry only one for the extremely small or extremely large." And also she said, maybe this is because of the clearance, where the clearance items, they have only 1 or 2 items. We checked it, and I realized that the phantom stockout happens across different sizes and not just clearance. Um, Another thing we thought about is that, well, I may not want to try on when I buy a very simple white t-shirt because I know the size and I don't want to bother for this cheap price. However, if I want to buy a formal suit, which is quite expensive, costly, I definitely want to try on in the fitting room to see whether it fits well. Okay, so in other words, we thought maybe those products used in the fitting room maybe are more high margin items, more expensive one. So we compared the average price of items left over in the fitting room with the 3,200 SKUs displayed in the same section that was $46. So it was consistent with what we thought. So essentially, those items are more popular and high margin products. This is a quote from a executive manager in Retailer B. He said, "Our most popular items are either in our customers' shopping bags or lying in the fitting room." So let me give you a summary for the second part, the field study. So we identify evidence for the two impeding behaviors. Why did I perform field study? Because we want to understand why so that we can provide solution. Okay, what is possible solution? One possibility is something called reduction strategy, according to the Frey. She's Harvard Business School the professor. So some stores, they have a limit in the number of items they can carry. Okay, so we ask for these two collaborating retailers to put something similar. And they said no because they don't want to bother customers' service. So yes, okay, alternatively, what we can do, is something called accommodation strategy. So, well, just let customers behave whatever they want, we can accommodate. So for the first impeding behavior, they occupy feeling longer. So we may want to speed up, but how? Can we just knock the door while using the fitting room? And or we can alarm it. So if you bring 3 items, you can have like 6 minutes and put the alarm on it. That's not possible because that bothers customers' service. Okay, so we can do that. But for the second one, they left over more items in the fitting rooms. We can have additional worker, or this, we hire one more employee here, and his job is just clean the room as soon as possible, and we can avoid this phantom stockout. So that was basically our idea. How about we have labor intervention, okay, to decrease the phantom stockout and increase sales. This is for the causal inference. Okay, we want to test whether our idea is really result in the positive outcome or not, and also we want to see how much. Okay, so simple design idea is as following: we can find two identical twin fitting rooms. For the one fitting room, we add a one dedicated labor so that this guy will clean up the fitting room as soon as possible. For the other twin fitting rooms, we don't have any dedicated labor. So this is control room. Control, and this is treatment. Okay, let's forget about this mathematical thing. Okay, so essentially, we found two fitting rooms. One is in the first floor, and the other one is in the second floor. And for the 4 weekend period, we use first fitting room as treatment and the other one as a control, and we switch the treatment and again switch the treatment again in the next period. Okay, so because we wanted to make sure that there's no issue because of selection bias and measurement errors. I can skip this part. Okay, so simply saying that when we do this experiment and compare the two fitting rooms, we found that the sales is increased by 22.7%. Okay, at the treatment fitting room compared to the control fitting room. One argument you may have is whether there's a positive ROI. In other words, given the fact that there is 40% of gross margin and $15 to $20 of hourly wage, is it really, this boost in sales is significantly more than this cost. And when we performed the analysis, we found that there is a positive ROI. We performed a second field experiment at another retailer because we got some pushback from the reviewers. Okay, two retailers, retailer A and B, has some commonalities and there's some differences like gross margin, the location, merchandise they carry, they're all different. And most importantly, the fitting room structure is notably different. Retailer A, they have centralized fitting room area. So all the fitting rooms are co-located in this center place. Okay. While the retailer B, this is a department store, so it has a decentralized fitting room. So it has 2 floors and it has multiple fitting room areas right next to each brand. Okay. So we found the result from the retailer B, okay, the decentralized fitting room area. So if we can show the same result from the centralized fitting room area, then we can argue for the generalizability. And as you can see, we got a very similar result from retailer A. Okay, and again, we have positive ROI. In summary, we had a simple design to perform the field experiment, and then we found that our labor intervention has mitigated the negative congestion effect, especially the phantom stock out. Stock out. Okay, so we are able to see that it has a positive impact on sales. Okay, there was the impact on the field experiment. So after we perform this result, we show the result to the retailer A. So our contact point was a CEO, and he was so excited. So he presented our result in the board meeting. And as you can imagine, the board members are very conservative. They said, okay, this is a result from just one store. So please perform a pilot study in 10 additional stores. Okay. And this pilot study, we were independent. Okay. This is purely managed by the CEO. And we were just told that from the CEO that they obtained a similar result. So after that, it was enrolled into, it was rolled out to all of the 100 stores. So they basically changes the way they operate because of our research. Retailer B, remember that was a department store. They essentially check the recovery rack after the 7 p.m. and put those items to the right place. And when I asked them why, they said they closed the store at 9 p.m. So after 7 p.m., there are very few customers out there. So they wanted to minimize any disruption in the sales floor. But after showing our result, they realized that this postponement of the replenishment has a significant negative impact. So they changed their policy in a way to continuously monitor their fitting rooms and reshelve those items. So that was really a valuable moment for me because I always want to do some research which can have a real impact. Okay, and of course, I cannot find the entire world, but I was able to have a positive impact on at least these two companies. So this last slide, okay, I mentioned about what is LSOM, LSOM, and I emphasized this service service operations a lot because that was my interest. And I also briefly mentioned what is digital transformation, business analytics, and coder inference. Through this application, this is about the retail industry. That's one example of service. This is one example of digital transformation because the data was newly available because of the traffic camera, which was not available in the past. This is an example of business analytics because thanks to this data, we performed the analysis and found there is a counterintuitive findings based on the invert shape relationship. And we just typically people just stop here, but we also want to provide a solution through the coder inference. Okay? Not just provide a solution, or we also measure its effectiveness, how good or how bad it is. Okay? So hopefully that provides you some interest to the LSM area, especially the service operations management. There's so many interesting things we can do under the service operations area. In the retail, in the healthcare, there is human aspects. Okay, how to mitigate the waiting time in the emergency department. Okay, so if you have any questions, if you want to know more about these kind of things, I highly recommend you taking some other courses offered by LSOM faculty. Okay. All right. Thank you for listening to lectures. I hope that was helpful. uh, and hopefully we can see you. We can see each other in the future in other courses. Okay. Thank you so much. Bye.